Welcome back. Last time, we talked about logical errors, those sneaky mistakes that happen because of the developer. But what if we could catch them before they cause trouble? That's where testing comes in. Testing is a crucial part of programming. It helps ensure your code works as expected and catches bugs early, saving you headaches down the road. In this video, we'll dive into two key types of testing in Python: manual testing and unit testing. By the end, you'll know how to test your code effectively and feel more confident in its reliability. Let's get started. Let's start with manual testing, the kind of testing you'll likely spend the most time on, and something almost every developer does regularly. This simply means running your code and testing different inputs to check for errors or unexpected behavior. While it's not automated, manual testing is often the first step in validating your code before moving on to more structured tests. For example, let's say we have a simple function that calculates the area of a rectangle. To manually test this function, we can call it with various inputs and check if the outputs match our expectations. By observing the results, we can spot potential issues. For example, should negative values be allowed? Should the length or height of 0 be valid? Manual testing forces you to think through edge cases and ensure your logic makes sense before moving forward. It's a simple but powerful way to catch mistakes early and improve your code. And as you've probably noticed, when it comes to manual testing, logging is your best friend. Now that we've manually tested our code, let's talk about unit testing. Something I'll admit I don't do as often as I should. And I really should. Unit testing means writing small, automated tests to check specific parts of your code, like individual functions or modules. It helps ensure they work as expected under different conditions, saving you from unexpected surprises later. Let's see how it works. In Python, we use the built-in unit test module to write and run automated tests. This allows us to check if our functions work correctly under different conditions without having to test them manually every time. Let's write a unit test for our calculate area function. First, we import the unit test module and define our function. Now we create a test case by defining a class that inherits from unittest.testCase. Test calculate area. This tells Python that this class contains test methods. Then, inside this class, we define functions. These are the actual tests. Each test method must start with test underscore, so unittest knows it's a test. If you're wondering why we use a class here, you can think of it as a structured way to group related tests. It's more than just a wrapper, but for now, we don't need to dive into that. We're just focusing on writing tests. Now, let's look at how we check if our function works. Here, self-assert equal is used to compare the expected output with the actual function result. It takes two arguments, the function call with test inputs and the expected result. So in simple terms, you're telling Python what to run and what the correct answer should be. If the output matches the expectation, the test passes. If not, it fails, helping us quickly catch mistakes. To run the tests, save the file and execute this command in the terminal. If all tests pass, you'll see a success message like this. That means no issues, your function works correctly for the tested cases. If a test fails, Python will print an error message showing which test failed, what the expected and actual output were. Unit testing is one of those things that might feel like extra work at first, but in the long run, it saves you time, effort, and frustration. Instead of manually testing your code every time you make a change, you can just run your test suite and within seconds, it tells you whether everything still works. But that's not all. Unit tests also make debugging way easier. If a test fails, it points you directly to the problem, so you don't have to waste time hunting down the issue in your code. Let's say we accidentally introduce a bug in our calculate area function. If we run our tests now, we'll see something like this. Instant feedback. The test expected 50, but it got 15 instead, which means our function isn't multiplying values anymore. Without unit tests, this mistake might go unnoticed until it causes real problems later. Another huge advantage of unit testing is that it gives you confidence when refactoring your code. Imagine you want to optimize or rewrite calculate area for better performance. With unit tests in place, you don't have to worry about breaking things. Just run the tests, and if they all pass, you're good to go. Even if you refactor the function, your code should still produce the same correct output. Without tests, you'd have to manually check every possible case every time you modify the function, which is tedious, slow, and error-prone. Unit tests also help you think through edge cases like what happens if a function gets unexpected inputs. For example, in calculate area, we might need to decide, should negative values be allowed? Should we raise an error if a parameter is missing? What if a non-numeric value is passed? By writing tests for these scenarios, we force ourselves to consider edge cases, making our code more robust. Plus, as your project grows, you might accidentally reintroduce old bugs, and trust me, it happens. Unit tests prevent this by ensuring previously fixed issues don't come back, a concept called regression testing. Unit testing might feel unnecessary for small scripts, but as soon as your code grows, it becomes a lifesaver. It saves time, makes debugging easier, helps with refactoring, and prevents regression bugs. If you want to write reliable code, unit testing is the way to go. Before we wrap up, let's go over some best practices for writing unit tests. Following this will make your tests clearer, more reliable, and easier to maintain. Test one thing at a time. Each test should focus on a single behavior or edge case. This makes it easier to understand what went wrong if a test fails. Instead, separate them. Use meaningful names. Your test names should be self-explanatory, so you instantly know what they check, instead of vague names like test underscore case underscore 1. This kinda looks like my file system. Go for something like test rectangle area positive numbers, or test rectangle area with 0. Cover edge cases. Think of unusual scenarios that could break your function. This is where real-world testing comes in. For example, what happens if we pass extremely large numbers? Floating point values, strings instead of numbers. Writing tests for these cases helps make your functions bulletproof. Run tests often. Don't wait until your code is done to run tests. Run them frequently as you develop. This catches issues early, saving you from debugging nightmares later. By following these best practices, you'll write clear, reliable, and effective unit tests. The more you test, the more confident you'll be in your code. Today, we explored 2 essential ways to test your Python code: manual testing for quick hands-on checks, unit testing for automated validation and long-term reliability. Testing might not be the flashiest part of coding, but it's what makes your programs strong, reliable, and ready for real-world use. And let's be real, I'm not glamorous either. I get my hands dirty with manual testing all the time. But here's the thing, unit testing is a powerful tool, and everyone should know how to use it. And as your teacher, I owe it to you to show you the best practices, even if it means pushing myself to get better at them too. So thank you for that. As they say, do as I say, not as I do. Now it's time to put this into practice. Try writing some unit tests for your own functions, or revisit an old project and test it properly. The more you practice, the better and more confident you'll become. And if you found this video helpful, don't forget to like, subscribe, and drop a comment below. Next episode, we're diving into command line arguments with argparse, a super useful skill for writing flexible Python scripts. Happy coding, and I'll see you in the next dimension.